This is problem 2 on practice exam 3 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. We have a graph that gives the flow rate through the aorta in the human heart. So part A, estimate the time when the flow rate is the highest. B, estimate the time t when the flow rate is changing the fastest. Part C, what's your estimate of the blood flow rate at t equals 0.3 seconds? And then the infinitesimal volume of blood, dV, that flows through the aorta in the infinitesimal time interval from 0.3 seconds to 0.3 seconds plus dt. So part A, the graph gives flow rate versus time. To get the highest flow rate, we just look at the highest point on the graph. So it's about a little bit after 0.25 seconds, about 0.25 seconds. That's where the peak is, right here. Part B asks when the flow rate is changing the fastest. So that's the maximum in df dt. I put absolute value signs there because it says change, it doesn't say increase. When is it changing the fastest? When I go over a little dt, when do I get the biggest df? When does it go up the most for a particular dt? And it looks like it's the steepest right in here somewhere. That's where it's really steep. If I go over dt here, I get a lot of df for a little dt. So maybe 0.23 seconds right here, 0.23 seconds, I'm guessing, somewhere in there, roughly. So on to part C, the estimate of the blood flow rate at 0.3 seconds. So 0.3 seconds is right here. I got to read off the horizontal axis. I'm going to put a horizontal line in there to help me do that. So that's 3.2, 3.4. It's between 3.2 and 3.4. It's closer to 3.4. It's over the halfway point. I'm going to call it 3.35 liters per minute. That's the flow rate through the aorta. Estimate. Pretty good estimate. So part D asks for what is the infinitesimal volume of blood dV that flows through the aorta in a time interval from 0.3 to 0.3 plus dt. If you haven't invested a lot of time thinking about it, pause the video and think about it. What's going on here? At 0.3 seconds, the flow rate is this. We estimated that the flow rate is dV dt. That's the definition. The definition of the instantaneous flow rate is dV dt. So dV dt at 0.3 seconds is about 3.35 liters per minute. We want dV. So we solve for dV. dV is the flow rate times the time. At 0.3 seconds, the flow rate is 3.35 liters per minute. That's problem 2.